Imagine this. You're sitting completely relaxed. Maybe you're reading a book. Maybe you're organizing papers at work. Maybe you're opening a package or flipping through a notebook. Then suddenly, a tiny edge brushes against your skin. At first, you don't even notice it. But 1 second later, a sharp burning sensation explodes through your fingertip. You immediately pull your hand back. You stare at your finger, and there it is. A paper cut. Tiny, thin, almost invisible. But somehow it feels worse than injuries that should be far more painful. And that raises a strange question. Why does something as harmless as paper create pain so intense that people instantly react like they've been? Why can a microscopic cut completely ruin your mood for the next several hours? And why does it keep hurting over and over and over again? The answer lies deep beneath your skin, inside one of the most advanced warning systems ever created by nature. Because paper cuts are not normal injuries. Scientifically speaking, they are almost perfectly engineered to maximize pain. To understand why, we first need to understand what pain actually is. Most people think pain is created by the injury itself. But technically, pain doesn't exist in the wound. Pain exists inside your brain. The injury is simply the trigger. The real experience happens in your nervous system. Every second of your life, your body is collecting information from millions of sensory receptors spread throughout your skin. These receptors constantly monitor temperature, pressure, vibration, texture, and danger. And among these sensors are special receptors called nociceptors. These are your body's pain detectors. The moment your skin gets damaged, nociceptors activate and send electrical signals racing through your nerves toward the spinal cord and into the brain. Your brain then interprets those signals as pain. But here's the important part. Your brain doesn't measure pain based on the size of the injury. It measures pain based on danger. And paper cuts trigger several danger signals at the exact same time. First, let's talk about the weapon itself. Paper. It doesn't look dangerous. It bends easily. It feels soft. You can crumple it with almost no effort. But under a microscope, paper looks completely different. The edge of a sheet of paper is not smooth at all. It's rough, jagged, and chaotic. Tiny fibers stick out everywhere like microscopic blades and hooks. Imagine dragging thousands of miniature saw teeth across your skin. That's essentially what a paper cut is. A knife creates a relatively clean incision. Paper creates microscopic tearing. And because the edge is so thin, all that force gets concentrated into an incredibly tiny surface area. Pressure increases dramatically. That allows paper to slice skin far more easily than most people realize. In fact, certain industrial papers are sharp enough to cut through protective gloves. Some photographers and factory workers even develop special techniques just to avoid repeated paper injuries. But the paper itself is only part of the story. The real reason paper cuts hurt so badly is where they usually happen. Your fingertips. Human fingertips are among the most sensitive structures on the entire body. And there's a reason for that. Your hands are your primary tools for interacting with the world. You use them to hold objects, sense textures, build things, protect yourself, communicate, and perform delicate movements. To make this possible, evolution packed your fingertips with an enormous number of sensory receptors. The density is incredible. Your fingertips can detect tiny differences in texture so precisely that you can feel grooves and patterns too small for your eyes to notice. But that sensitivity comes at a price. When paper slices into your finger, it attacks one of the densest nerve networks in your entire body. That tiny cut instantly activates a massive number of pain receptors at once. Your nervous system reacts aggressively because your brain considers hand injuries extremely important. From an evolutionary perspective, damaged hands could mean death. Imagine ancient humans surviving in dangerous environments. A hand injury could prevent climbing, hunting, building shelter, starting fires, or defending against predators. Even small infections could become fatal before modern medicine existed. So your brain evolved to protect the hands at all costs. That's why even tiny injuries to the fingers can feel disproportionately painful. Your nervous system treats them like emergencies. But here's where things get even stranger. Small cuts often hurt more than bigger ones. That sounds completely backwards. Most people assume large injuries equal large pain. But pain is far more complicated than that. Deep knife wounds sometimes cut cleanly through nerves. Because paper cuts are so irritating, your brain remembers them extremely well. Humans evolved to remember painful experiences that might help avoid future danger. So after enough paper cuts, your brain begins reacting faster and more dramatically whenever it senses similar injuries. In other words, your past paper cuts can actually make future paper cuts feel worse. Your nervous system becomes more alert, more defensive, more sensitive, and modern life only increases the problem. Think about how much paper humans interact with daily: books, packaging, receipts, documents, mail, money, notebook paper, sticky notes, magazines. For thousands of years, humans lived without exposure to these ultra-thin processed paper edges. Modern manufacturing accidentally created one of the most annoying tiny hazards in human civilization. And despite all our advanced technology, paper cuts remain undefeated. No matter how intelligent humans become, no matter how advanced medicine gets, a random sheet of paper can still instantly humble almost anyone. And honestly, there's something strangely impressive about that. Because scientifically, paper cuts are almost the perfect pain trap. A microscopic jagged blade, attacking highly sensitive fingertips, exposing nerves without destroying them, triggering inflammation, creating constant irritation, receiving non-stop stimulation through daily movement, and amplified further by surprise and attention inside the brain, all combining together to create pain wildly disproportionate to the actual damage, which explains why people react so dramatically to something so tiny. It's not weakness, it's biology. Your nervous system is doing exactly what evolution designed it to do. Protect the hands, protect the nerves, protect the body, even if the threat comes from something as ordinary as paper. And maybe that's the strangest part of all. One of humanity's greatest inventions, the thing used to spread knowledge, history, science, stories, money, laws, and ideas across the world, also hides millions of microscopic blades along its edges, quietly waiting for the perfect moment to strike your fingertip and ruin your entire day. In certain cases, the nerves are damaged so quickly and completely that pain signals temporarily decrease. Adrenaline can also suppress pain during serious injuries. That's why some people don't immediately realize how badly they've been hurt after accidents. Paper cuts work differently. They are shallow, very shallow. That means the nerves aren't destroyed. They're exposed, irritated, and repeatedly stimulated. Imagine peeling the insulation off a live electrical wire. The wire still works, but now every tiny contact creates intense reactions. That's what happens with exposed nerve endings in a paper cut. Air touching the wound hurts. Water touching the wound hurts. Soap becomes torture. And alcohol-based sanitizer feels like pouring fire directly into your skin. Because the nerves remain alive and hypersensitive. And unfortunately, the suffering doesn't stop there. Your immune system immediately joins the chaos. The moment your skin barrier breaks, your body launches an emergency repair response. Blood vessels around the injury expand. Immune cells rush toward the damaged tissue. Inflammatory chemicals flood the area. One of those chemicals is histamine. Histamine helps increase blood flow and supports healing, but it also makes the surrounding nerves far more sensitive. That's why paper cuts often develop a burning or throbbing feeling shortly after the initial injury. Your body is basically increasing the pain intentionally. It wants you to protect the damaged area while healing occurs. And then there's another major problem. Paper cuts usually don't bleed much. At first, that sounds like a good thing. But deep bleeding actually serves an important purpose. Blood helps clean wounds. It flushes away debris, bacteria, and damaged cells. Paper cuts are often too shallow for strong bleeding. So tiny fragments of paper, dirt, and bacteria can remain trapped near the surface. Meanwhile, the wound stays open and exposed to the environment. And because your hands constantly touch things, the irritation never really stops. Think about how often you use your fingers. Typing, opening doors, using your phone, washing your hands, picking things up, cooking, driving. Every movement stretches the skin around the cut. Every contact stimulates the exposed nerves again. That's why paper cuts seem impossible to ignore. Your own body keeps reactivating the pain every few seconds. And there's another fascinating psychological reason these injuries feel so intense. Your brain absolutely hates unexpected pain. If a boxer gets punched during a fight, the brain is prepared. If a chef cuts a finger while chopping vegetables, the brain understands the risk. But paper cuts happen during calm, harmless situations. You're doing paperwork, reading, studying, opening mail. Your brain does not expect danger. That surprise actually amplifies the pain experience. Scientists have discovered that unexpected pain often feels more intense because the brain rapidly shifts attention toward the threat. And once your brain focuses on pain, it becomes difficult to ignore. In simple terms, the more attention you give pain, the worse it feels. And paper cuts are masters at stealing attention. They happen on highly active body parts. They sting repeatedly. And they constantly remind you they exist. But there's another reason paper cuts are uniquely horrible. Their shape. Most paper cuts are thin and narrow. That means the edges of the wound sit extremely close together. As the skin moves, those tiny edges repeatedly rub against each other. That friction creates even more irritation. Sweat can also enter the wound. Salt from sweat activates exposed nerve endings even more intensely. That's why a paper cut can suddenly start burning for no obvious reason. Even changes in temperature can trigger pain. Cold air, warm water, dry skin, everything becomes noticeable. And strangely enough, different types of paper can create different levels of pain. Thin printer paper is notorious because its edges are sharp and stiff. Glossy magazine pages can slice surprisingly easily because of their coated surfaces. Freshly cut cardstock can behave almost like a razor. Currency paper has also caused countless painful cuts around the world. In some factories, workers handling large volumes of paper actually wear protective equipment because repeated cuts become a serious occupational problem. And while most paper cuts are harmless, infections are still possible. Your skin is your body's armor. The moment that barrier breaks, bacteria gain a pathway inside. Usually, your immune system handles it quickly, but occasionally, bacteria multiply inside the wound. Redness spreads. Swelling increases. The area becomes warm and tender. In severe cases, pus can form, all from a cut so small you could barely see it. And here's something even more fascinating. Your memory plays a role too.